Hello everyone, welcome to PM Networking. Guys, today we are going to start a new Cisco certification course where we are going to cover CCNP in Core plus NRC. Definitely we will cover every topics of CCNP in Core and NRC, and hope you guys will like this series, you guys will like this video. So please, only one request to everyone, please give your feedback, give your review after watching this video. You are going to learn from industry expert. So without wasting our time, let's begin.
Hello everyone. Today we are going to start CCNP routing and switching. In new terms, if I'll say we are going to do the encore for routing and switching. So first of all, I'll show you the topics which we are going to cover in this session. So I'll be taking around 40 to 45 sessions for this CCNP, and we will be covering various topics of routing and switching. Apart from it, we will also be covering the wireless and SD-WAN, which are new introduction to this routing and switching domain. So, day-wise topics, as you can see on your screen, there are multiple day-wise topics, and we will cover them one by one. So, total days which I have written is around 66, but I'll try to cover all of them uh, in around 40 days, let's say 40 to 45 days, we are going to cover these topics. First of all, before starting these topics, your CCNA routing and switching must be clear because all these topics are advanced and you will be covering it completely as per the Cisco process, Cisco syllabus, you can say. Now, first of all, you must be familiar with two of the two terms. The first one is NCore, which is Network Core, and the second one is NRC, which stands for Enterprise Advanced Routing and Services. So basically, it is a domain which is of advanced level, and you can cover multiple routing topics like EIGRP, OSPF, BGP. Apart from it, we are going to cover switching, which consists of multiple topics like spanning tree, dynamic trunking protocol, VTP, and Ether channel is also one of the important topic which is covered and which is widely used in the enterprise network. So basically, all these things will be used in the enterprise network, how we can build the enterprise network, which all topics will be covered or protocols will be used to build an enterprise network. So we can cover from here. Apart from it, as I told you, that in the last I'll be covering some of the advanced things like wireless. I'll be giving 2 to 3 days for the wireless. As you know, wireless is one of the trending things which is widely used in the enterprise network. How the access point works, what is the use of WLC, wireless LAN controller, how they will be configured, all these things will be covered in the session. Now, let's see these topics one by one. So, first few days will be contributed towards the switching part. You must be clear with the switch. What is a switch? How switch functions? What is the work of switch? How it will work? All these things must be clear to you. These are some of the basic stuff like TCP/IP model. TCP/IP model is a reference model which is used nowadays. Layer 2 forwarding says like how a switch will forward a traffic. This will be covered in packet flow. Apart from it, MAC address table content. A switch learns MAC addresses. If you know and if you have studied in CCNA, you must be aware of MAC address table. So we are going to see what are the contents of this MAC address table. After that, what are VLANs, virtual local area networks? It will be done from starting. Introduction would be there. After that, configuration part would be there. After that, types of VLANs. How many types of VLANs do we have? Standard VLANs, extended VLANs. Trunking. What is trunking? How do switches form trunk links? What is the protocol used for trunking? Its name is DTP, Dynamic Trunking Protocol. After that, if you make an interface trunk in between switches, the link the trunk link will have a native VLAN. What is the use of native VLAN? What is tagging? And how this native VLAN is used to forward non-tag traffic. We will cover this. After that, trunk links, access links, DA stands for dynamic auto and dynamic desirable. These will be covered. After this, the dynamic auto and dynamic desirable, these are two modes in the TP dynamic trunking protocol. After this, the concept of sub interfaces will be covered. Sub interfaces means like if we have a router and that router have one interface connected with a switch, we can create sub interface of this physical interface so that different VLAN traffic can be forwarded through this link. So it will be done with the help of sub interfaces, and the complete concept is known as router on a stick. After that, forwarding architecture of a switch, there are multiple methods through which a switch can forward the traffic. It can be process switching, it can be Cisco Express forwarding. Now here CEF stands for Cisco Express forwarding, this one. So Cisco Express forwarding is by default enabled on Cisco switches. Now how CEF works, we will be covering this. After that, one of the important topics of switching will be spanning tree protocol, STP. It is widely used and it is used to avoid the loops in bridging environment, or we can say layer 2 loops can be avoided with the help of spanning tree. Now there are multiple parts of spanning tree which we need to learn, like what is a root bridge, what are the elections of root bridge. After that, we need to cover the modes. There are different modes and states in spanning tree of particular port. For example, if I say the interface of a switch can be in forwarding state or in blocking state, it will be depending on the role of that interface. The interface have to be in no, not dynamic desirable. The interface have to be in, for if it is in forwarding mode, it have to be what do we say, root port or designated port. Yes, it is root port or designated port. And if it is blocking port, if it is in blocking state, then the interface of switch have to be an alternate port. So we will be covering this in spanning tree basics. After that, we will also learn how we can calculate a loop free topology. Apart from it, as I told you, root bridge manipulation can be done. It can be done with the help of priority value, cost manipulation, and we are going to learn about the spanning tree port states. This we will be learning. After that, spanning tree will take some time, around 4 to 5 sessions will go in spanning tree as it is one of the important topics. Then we will be learning about the different modes of spanning tree, like PVST plus, what is PVST, PVST plus, CST, difference in between them. After that, RSTP, rapid spanning tree protocol, we are going to cover this. Apart from it, we have MST. So all these things will be covered in spanning tree topic. After that, once the spanning tree is covered, now it might take 5 to 6 days to cover these topics of spanning tree. Once the spanning tree is covered, then we are going to learn about VTP. Now remember, all these topics till now which I have told you are part of switching. Now switching will be done till this portion, which is ether channel. This will be complete switching. Apart from it, routing will be starting from this day, 17th day. Now, the last topics of spanning tree would be, not spanning tree, switching would be ether channel. What is ether channel? Why we bundle the interfaces in between the switches? What is the benefit of the ether channel? How we can bundle the links statically or dynamically? We can use two protocols, PAGP, LACP, port aggregation protocol, and after that LACP stands for link aggregation control protocol. So these will be covered in switching part. After that, we are going to cover routing. Now in routing, static routing is one of the important things, and we need to learn the packet flow of this. After this, once the static routing is done, I'm also going to discuss default routing in this. What is default routing? We will also cover this because these are some of the small topics which you might have covered in CCNA. So we are not going into depth, but we will be for sure doing some practicals of this. After that, we will be covering EIGRP. EIGRP is an advanced distance vector routing protocol. How EIGRP works, what are the basics? There are 5 messages in EIGRP. What are those messages? How neighborship is formed in EIGRP? What is the metric calculation process of EIGRP? How we can calculate the metric? What is dual algorithm, diffusion update algorithm? How it works? What is the use of dual? We are going to cover this. After that, EIGRP. Once EIGRP is covered, I'm going to cover all the things like route summarization, what is summarization, EIGRP authentication, offset list, unequal cost, load balancing, route filtering. Each and everything will be done practically in EIGRP. Once EIGRP is covered, we will move on towards next routing protocol, which is OSPF. Now, open shortest path first, it is one of the important protocols for routing. It will be or it is used in every enterprise network. आपको कहीं ऐसा मिलेगा ही नहीं कि EIGRP, sorry, not EIGRP, OSPF use ना हो रहा हो. One of the important protocols, routing protocols. Once OSPF is covered, now point to remember over here is that I'm going to cover all the LSAs, which are LSA 1, 2, 3, 4, 5, and 7. All these LSAs will be covered in this session. इस सेशन के अंदर ये सब कवर होगा इन OSPF. Once OSPF is done, we are going forward with the redistribution part. What is redistribution? How we can do redistribution? And now redistribution. What is redistribution? There is a question. There will be a question in your mind. Like, let's say there are 3 routers. Let me explain it to you right away. Easy. One of the easy things. Let's say we have few routers. This one is router 1, this one will be router number 2, and this one will be router number 3. And I'm saying that router 1 and router 2 are running OSPF. Right? And router number 2 is running EIGRP with router number 3. Now in this scenario, OSPF routes will not be advertised by EIGRP automatically. No, it will not be done automatically. It will be done once we enable or once we configure router 2 with the commands of redistribution. That means we have to redistribute the OSPF routes into EIGRP. Done. So this is why redistribution is needed, and how we are going to do it with the help of configuration or commands, we will discuss it later. Now after this, BGP. BGP stands for Border Gateway Protocol. BGP is one of the important protocols which is used in the edge of the network. If you say that we want to communicate with our ISP, at that point of time, EBGP will be used. Now, what is the difference in between EBGP, IBGP? EBGP stands for Exterior Border Gateway Protocol. IBGP stands for Interior Border Gateway Protocol. What is difference? When we will be using EBGP and IBGP, we will cover this all the configuration part, but BGP is one of the vast protocols, one of the vast routing protocols this one is. So we will be covering this in the session. After that, I'll not be covering IGMP, which is the part of multicasting, and apart from it, we are not going to cover quality of service, because these are some of the advanced topics which can be done further once all these other topics are covered. So quality of service and multicasting will not be done in our session. After that, first hop redundancy protocol, FHRP. We will be covering FHRP. There are 3 protocols in FHRP. The first one is HSRP, hot standby routing protocol. After that, VRRP is one of the important protocols. Let me write it down here. It will be VRRP. After that, the last one will be GLBP, not God, sorry, Gateway Load Balancing Protocol. Gateway Load Balancing Protocol is Cisco proprietary. Why we use it? What is the use of first hop redundancy protocol? We are going to cover this in this session. After that, NAT, Network Address Translation. What is static and dynamic NAT, PAT, Port Address Translation? All will be done. NTP is different from NAT. NTP stands for Network Time Protocol. Network Time Protocol is basically used to synchronize the time in between the devices. If we want to set the same time stamp on a device, then all the devices will be running NTP. After that, we are going to cover SNMP. SNMP stands for Simple Network Management Protocol, syslog. Both of these protocols are related to the log messages, and these are used to take the report from a device so that we can determine if a device is working fine or not. Simple Network Management Protocol, SNMP, and syslog. SNMP is one of the important key topics which is always asked in interviews. After that, we will not be covering DMVPN, IPsec phase 1 or IPsec in this session. NetFlow not required. Yes, we are going to cover IPv6, and in IPv6 I'm going to show you how we can do the static routing, and we are also going to learn how we can run IPv6 or we can run OSPF with IPv6. What is OSPF version 3? It is basically used to run the OSPF for IPv6 only. After that, we will be covering some of the important topics related to the software-defined network or tunneling. First of all, what is overlay network, underlay network? We will be covering this GRE protocol, generic routing encapsulation tunnel, how it is created. Now, I don't think there is any need to learn the IPsec session over here. But after that, we will be covering Lisp, VXLAN. What is VXLAN? What is Lisp? What is virtualization? What is hypervisor? Types of hypervisor, hard hypervisor, all that stuff. After that, software defined network, SD-WAN. What is SD-WAN? What is SD access? We are going to cover these topics. It may not take much time because we are going to cover all these software defined topics in theoretically. We are not going to do practicals for these. After that, in the last, we are going to cover wireless. I'm going to take 2 to 3 days for the wireless topics. And this is how we will be covering CCNP or NCORE topics. Now, everyone, moving forward towards the first day topics, I'm going to show you how layer 2 forwarding is done. Now, this will be done, or the tools which I'm going to use for this CCNP session will be Cisco Packet Tracer. After that, GNS3. After that, handwritten notes will be there, which I'll provide you. Apart from it, if needed, I am going to run IOU in VMware to do some of the practicals. Right now, the first thing is that all these tools are free of cost and you can download them from the web. But obvious, handwritten notes are not free of cost. I'm going to prepare these notes for you guys. So, how layer 2 forwarding is done, how switch learns the MAC address, what is the content of MAC address table. Today I'm going to show you this in Cisco Packet Tracer. Now, first of all, let's open Cisco Packet Tracer. Now, to see switch function, how switch functions, what I'm going to do is I'm going to take one switch, layer 2 switch, and I'm going to attach few devices. Now, those devices will be few computers, and let's spice up things. I'll take one access point and I'm going to join this access point with the switch, and let's wait. Okay, see, I'm going to join these two PCs with the switch directly, This switch will be connected with this access point, and this PC will be connected with this access point. Now I need to see that how. Done. Now, what is this access point? Right? Mhm. Okay, but before that, where is my Epic pen? Guys, give me a minute. Yes. So, what is this access point? We need to learn about it. First of all, access point is a wireless and wired device which is going to connect the wireless or the different devices wirelessly. ये एक ऐसा डिवाइस है जो वायरलेस डिवाइसेस को कनेक्ट करने के काम में आता है. नाउ वी नीड टू फोकस ऑन दिस स्विच. हमारे को इसके ऊपर फोकस करना है. वी नीड टू लर्न द लेयर 2 फॉरवर्डिंग. राइट. And also before that, let's see the labels or the interfaces. See, if I'll zoom in, we can see that PC1 is connected with fast Ethernet 0 by 1, PC2 is connected with fast Ethernet 0 by 2, PC3 is connected with this access point, and this one is PC number 2. Let's label it as PC0, PC1, PC2, right? PC2 is connected wirelessly. Now what I'm going to do is I'm going to provide the IP addresses to these devices. First of all, IP address of PC0 will be 10.1, PC1 will be 10.2, and PC2 will be 10.3, right? Cannot launch the PC software because effective data certificates. Okay. Desktop IP configuration 10. IP address will be 10.1. I hope everyone knows how to provide the IP address to PC in this packet tracer. This will be 10.2, right? And this will be 10.3. Now, I'll also write it down over here. But how? How I'm going to write this down? Yeah, here it is. So this one will be PC0, IP address is 10.1, and I'm also going to note down the MAC address of this PC. It is important. We need to see how things are working, how switch is learning MAC address. So the MAC address of this PC is, in the last it is D1CE, right? PC number 1, IP address is 10.2. Let's take the MAC address. Configuration fast Ethernet 0. This will be the MAC address of PC number 1. I'll note it down. PC1, IP address 10.2, MAC address will be 4394, and as you can see in the last, this will be PC2. Oh, sorry. PC number 2. 10.3 is the IP address, and we need to check the MAC address. I'll go to configure fast Ethernet 0, copy and then paste the MAC address. Now I am doing this to show you the MAC addresses of these PCs, nothing else. After this, once we have noted down each and everything, what I'm going to do is I'm going to connect this PC with this access point. First of all, how I'm going to activate this access point, it is like power is on. See, power is on. I'll go to global settings. The name is access point 0, interface 0. It is working on 100 Mbps. Port status is on. After that, now what is this SSID? The name of Wi-Fi will be default, and there is no, you can say, authentication done, right? हमें कुछ नहीं करना है यहाँ पर. I'm going to use it as it is. I'll go to PC. In PC, I'll go to physical. Let's see if I can attach the wireless module. I need to check which one is the wireless module over here. I'm not sure. What we will do is we will not take PC. Let's take a laptop over here in place of PC. Because in laptop, I think I can add the wireless module, which is going to be connected with this access point. Now why I am not getting, okay, got it. See, we have one laptop over here, right? Let me give the IP address 10.3 over here. And I'll rewrite the MAC address, but before that, let's connect the wireless module. Now, I'm not sure what is the name of that wireless module. I think this one would be. Mhm. I'm not able. Okay, done. Now I think I'll be able to attach it. Let's see if it is wireless. I think we do not need this to be done. WMPA 300N. Okay. Do we have WNPA? Yeah, here it is. Okay. Let's power off this. Let's remove this module. Let's add this one and then power on machine. Done. IP address D static 10.3. Done. See, wirelessly I'm going to connect it. Now I need to connect this with the SSID whose name is default. See, here it is. दिख रहा है? Default आ गया ना? We need to connect it. That's it. It will be connected automatically. See, you can see it is connected. Wirelessly, this laptop is connected. Now, how layer 2 forwarding will be done? I have the MAC addresses. Now, what I'm going to do is we will just go to command prompt and I'll ping 10.0.0.3 wireless device. Let's see if we can ping it or not. Let's see. It is unreachable. Right now it is unreachable. ओके वायरलेस की सेटिंग्स शायद से देखनी पड़ेगी. I'll have to see it. I think it is connected. More information. Wireless network name, default, IP address. We are not getting any IP address for this device. आई थिंक हमारे को DHCP सर्वर भी सेटअप करना पड़ेगा इसके लिए. लेट्स डू वन थिंग. आज इसको हटा देते हैं. वी विल नॉट कवर दिस. फिर कभी बताऊंगा क्योंकि इसके लिए मुझे एक DHCP सर्वर भी सेट करना पड़ेगा जो IP एड्रेस प्रोवाइड करेगा क्लाइंट को. माइट बी. वी विल डू दिस प्रैक्टिकल विद 2 PCs ओनली. आई एम गोइंग टू पिंग PC1 10.2. PC1 will be pinging 10.2. देखिए reply is coming from 10.2. Now you must know that when you ping from one device, the protocol used is known as ICMP, Internet Control Message Protocol, and it works at which layer of OSI model? It works at layer 3 of OSI model. जब यहाँ से अब ICMP के दो पैकेट्स होते हैं. There are two packets of ICMP. The first one is ICMP echo request and the second one is ICMP echo reply. Right? Now यहाँ से ICMP को request जाएगा. Right? It will take the source MAC address as MAC address of PC0 which is CE in the last. Last में देखो CE है ना यहाँ पर. And the destination IP address will be 94. Now layer 2 forwarding. First of all, switch function is to learn the MAC address. Switch क्या करेगा? Learn करेगा. किसको learn करेगा? MAC address को learn करेगा. In this packet, the switch will learn MAC address CE from which interface? Fast Ethernet 0/1. I can prove it to you how. हम switch का access लेंगे, इसके CLI में जाएंगे और यहाँ पर मैं आपको command run करके दिखाऊंगा. Enable mode के अंदर जाके show MAC address table. जरा ध्यान से देखिए 0/1 interface से कौन सा MAC address learn कर रखा है. 1 CE लर्न कर रखा है? मैंने यही बताया था आपको थोड़ी देर पहले कि 0/1 से ये CE यानी कि सोर्स मैक एड्रेस लर्न करेगा एंड इट विल फॉरवर्ड दिस पैकेट टू 94, जिस इंटरफेस से 94 लर्न कर रखा है। जरा एक बार ध्यान से देखिए, फास्ट इथरनेट 0/2 कौन सा मैक एड्रेस लर्न कर रखा है स्विच ने? 94 वाया 0/2। दैट मीन्स इसका मतलब ये हो गया कि इस सिनेरियो के अंदर ये पैकेट यहां पर क्या हो जाएगा? इट विल बी unicast. The packet will be unicast towards PC1. Why? Because switch have learned the MAC address of PC1. Got it? This is how layer 2 forwarding is done by a switch. Switch सिर्फ और सिर्फ source MAC address को learn करता है, अपनी MAC address table से MAC address को देखकर उस particular interface के through packet को forward कर देता है. If I am going to look in the content of MAC address table, you are going to see पोर्ट नंबर, किस पोर्ट से मैक एड्रेस लर्न किया, लर्न मैक एड्रेस, कौन सा मैक एड्रेस लर्न कर रखा है, बट इज द टाइप. नाउ टाइप here stands for the MAC address is learned dynamically or statically. That means we can also provide the MAC address to the switch statically. मैं एक switch के ऊपर statically भी MAC address learn करवा सकता हूँ. How we can do it? It's very easy. Global configuration mode में जाओ, यहाँ पर लिखो MAC address table static. आफ्टर दैट मैक एड्रेस, जो भी मैक एड्रेस होगा, आई से 0.000 ए दे दिया मैक एड्रेस. VLAN नंबर मैंने 1 रखा है यहाँ पर. इंटरफेस विल बी फास्ट ईथरनेट 0/1. दिस इज द कमांड टू गिव द स्टैटिक मैक एड्रेस इन अ स्विच. मैंने स्टैटिकली मैक एड्रेस लर्न करवा दिया. कौन सा? ऑल जीरोज, लास्ट में ए, VLAN 1, इंटरफेस नंबर 0/1. यू कैन सी द टेबल, डू शो मैक एड्रेस टेबल. जरा ध्यान से देखिए, अब स्टैटिक एंट्री आ चुकी है मैक एड्रेस टेबल के अंदर. वन थिंग टू रिमेंबर इज अ डायनेमिक मैक एंट्री, एक एंट्री मैक एड्रेस टेबल में कितनी देर तक रहती है? ओनली फॉर 300 सेकेंड्स. बट एक स्टैटिक एंट्री परमानेंटली यहां पर रहेगी जब तक मैं इस कमांड को यहां से रिमूव नहीं करूंगा. डन. सो दिस इज हाउ वी कैन गिव द स्टैटिक मैक एड्रेस टू अ स्विच. स्विच करता क्या है? बेसिकली स्विच के दो फंक्शन होते हैं. व्हाट आर द फंक्शंस ऑफ स्विचेस? सी, फर्स्ट फंक्शन विल बी switch will learn MAC address of which MAC address? I'm going to write it in a bracket. Source MAC address of a incoming packet. Of an incoming packet. एक अपनी तरफ आ रहे पैकेट का सोर्स मैक एड्रेस कौन लर्न कर लेता है? स्विच, विद इट्स पोर्ट नंबर. एंड द सेकंड थिंग इज switch will forward the packet by checking its MAC address table. वो अपनी मैक एड्रेस टेबल को चेक करके पैकेट को क्या कर देगा? फॉरवर्ड कर देगा. नाउ दिस इज हाउ स्विच फंक्शंस. इस तरीके से स्विच क्या करता है? काम करता है. एंड स्विच इज अ डिवाइस, लेयर टू डिवाइस, जो अलग अलग मल्टीपल डिवाइसेस को कनेक्ट करने के काम में आता है इन सेम नेटवर्क के अंदर. राइट. आफ्टर दिस एक क्वेश्चन मेरे माइंड में आया. क्या क्वेश्चन मेरे माइंड में आया? लेट्स सी. देखो, देखिए, लेट्स से मैंने एक और पीसी अटैच कर दिया. 10.3 इसका आईपी एड्रेस हमने यहां पर दे रखा है ऑटोमेटिकली. नाउ इन दिस सिनेरियो व्हाट आई एम सेइंग इज, ये जो PC1 है ना, लेट्स से इसने एक ट्रैफिक सेंड किया. राइट. इसने क्या किया? एक ट्रैफिक सेंड किया. एंड द डेस्टिनेशन मैक एड्रेस ऑफ दिस ट्रैफिक इज, क्या है डेस्टिनेशन मैक एड्रेस इस ट्रैफिक का? लेट्स से XYZ, कुछ भी. मैंने बोला 000B. लास्ट के 4 कैरेक्टर्स ये वाले हैं, स्टार्टिंग के कुछ भी हो सकते हैं. राइट. स्विच क्या करेगा? अपनी मैक एड्रेस टेबल को देखेगा. स्विच क्या करेगा? अपनी मैक टेबल को देखेगा. लेट्स सी, स्विच के पास क्या कोई 00B नाम का मैक एड्रेस है इसकी टेबल में? शो मैक एड्रेस टेबल. नहीं है, नहीं है ना यहाँ पर कोई 000B. नाउ आपके हिसाब से अगर स्विच की मैक टेबल में एंट्री नहीं है, व्हाट इज स्विच गोइंग टू डू? क्या ये स्विच इस ट्रैफिक को ड्रॉप करेगा? नो, ये इस ट्रैफिक को ड्रॉप नहीं करेगा. देयर इज अ कंसेप्ट नोन एज अननोन यूनिकास्ट फ्लडिंग. अब ये अननोन यूनिकास्ट फ्लडिंग का मतलब क्या है? देखो, इसको मैं 3 वर्ड्स में डिवाइड करता हूं. अननोन, अननोन का मतलब, अननोन मीन्स द मैक एड्रेस इज unknown to the switch. Switch do not know the MAC address. Unicast means this MAC address or this packet have to be forwarded to a particular destination. That means this packet is going to be unicast. Flooding means if switch do not knows the MAC address of this unicast traffic, in this case switch is going to flood it. Switch इसको क्या करने वाला है? Flood करने flood करने वाला है. मतलब what do you mean by this? इट मीन्स स्विच के पास जब ये ट्रैफिक आएगा, स्विच अपने सभी एक्टिव पोर्ट से इसको आगे फॉरवर्ड कर देगा. दिस इज नोन एज अननोन यूनिकास्ट फ्लडिंग. बट आपके माइंड में एक सवाल आया, यू टोल्ड मी दैट इट इज इक्वल्स टू ब्रॉडकास्ट. क्या हम इसको ब्रॉडकास्ट बोल सकते हैं? नो, वी विल नेवर से इट एज अ ब्रॉडकास्ट. रीजन क्या है? देखिए, जब भी अननोन यूनिकास्ट फ्लडिंग का कोई ट्रैफिक आता है, उसका जो डेस्टिनेशन मैक एड्रेस होगा, व्हाट विल बी द डेस्टिनेशन मैक एड्रेस? द डेस्टिनेशन मैक एड्रेस ऑफ दैट पैकेट विल बी समथिंग लाइक अ यूनिकास्ट मैक एड्रेस. एक यूनिकास्ट मैक एड्रेस होगा, यानी कि एक डिवाइस का मैक एड्रेस होगा. बट इन ब्रॉडकास्ट द डेस्टिनेशन मैक एड्रेस इज गोइंग टू बी all F. This is the difference in between broadcast and unicast. आगे कभी जब हम प्रैक्टिकल करेंगे तो मैं आपको दिखाऊंगा. डेस्टिनेशन मैक एड्रेस अगर ऑल एफ होता है तब हम कहते हैं कि ये पैकेट ब्रॉडकास्ट होगा. अगर डेस्टिनेशन मैक एड्रेस किसी पर्टिकुलर डिवाइस का मैक एड्रेस है, दैट मीन्स इट इज अ यूनिकास्ट ट्रैफिक. एंड अननोन यूनिकास्ट फ्लडिंग का मतलब, अगर स्विच की मैक एड्रेस टेबल में एंट्री नहीं है, देयर इज नो मैक एड्रेस टेबल एंट्री इन स्विच, मैक एड्रेस की एंट्री नहीं है टेबल में, उस केस में स्विच इसको अपने सभी एक्टिव पोर्ट से आगे फॉरवर्ड करेगा. सो पॉइंट्स टू रिमेंबर आर, द फर्स्ट पॉइंट इज दैट switch will learn the source MAC address of incoming packet, switch will forward that packet by checking its MAC address table, and if the MAC address entry is not in table, then the switch will flood that packet from its active ports. आप मुझे बोलोगे क्या मैं ये करके दिखा सकता हूँ प्रैक्टिकली? यस, वी कैन सी इट. बड़े आराम से देख सकते हैं हम इसे. हाउ? सी, वी विल हैव टू वेट फॉर 4 आवर्स. नहीं, मैं एक नया सेटअप ले लेता हूँ. ठीक है, नया सेटअप लेने की जरूरत नहीं है, एक नया स्विच ले लेते हैं. ठीक है, आई एम गोइंग टू कनेक्ट दिस स्विच. हमने पहले ही आईपी एड्रेसेस दे रखे हैं. डन, हमने कनेक्ट कर दिया स्विच. आफ्टर दिस मैं यहां पर सिमुलेशन मोड में जाके आईसीएमपी पैकेट को देखूंगा एंड एंड लेट्स सी, जब हम यहां से पिंग करते हैं तो यहां पर एक पैकेट जनरेट होता है, राइट? इस पैकेट का देखिए, आईसीएमपी का पैकेट जनरेट हुआ है अभी, दिस वन. इस पैकेट का देखिए डेस्टिनेशन मैक एड्रेस क्या है? 4394, राइट? स्विच की टेबल में एंट्री है, लेट्स चेक 4394 है क्या इसके पास? राइट, अभी है इसके पास मैक एड्रेस. लेट्स डू वन थिंग, I'll fast forward the time. मैं एंट्री हटा देता हूं टेबल से. 300 सेकेंड्स तक होती है एंट्री. एनेबल शो मैक एड्रेस टेबल. देखिए अब कोई एंट्री नहीं है. नाउ what I'll do is सिमुलेशन मोड पे लाकर अब पिंग करते हैं. पिंग 10.2. See, ICMP packet, Ethernet header to destination MAC address is 4394, but switch do not have this entry in its table. दोबारा देख लो, नहीं है entry. Switch is going to do the unknown unicast flooding. ये पैकेट स्विच के पास जाएगा, बट नाउ स्विच इज गोइंग टू फॉरवर्ड दिस पैकेट टू ऑल द एक्टिव पोर्ट्स. देखो, है ना, दिस इज अननोन यूनिकास्ट फ्लडिंग. इस डिवाइस के लिए ट्रैफिक था, इसने रिप्लाई बैक किया और फॉरवर्ड कर दिया ट्रैफिक, राइट. सो आपने देखा कि अननोन यूनिकास्ट फ्लडिंग के अंदर डेस्टिनेशन मैक एड्रेस एक डिवाइस का मैक एड्रेस होता है, बट सेम टाइम इफ आई एम गोइंग टू सी अ ब्रॉडकास्ट, मैं एक अलग प्रोटोकॉल का यूज कर रहा हूं यहाँ पर, आर्प एड्रेस रेजोल्यूशन प्रोटोकॉल. इस पीसी से पिंग करते हैं 10.1 को. जब मैंने इसको पिंग किया, आई कैन सी अ ट्रैफिक, आर्प का ट्रैफिक है ये, बट सी डेस्टिनेशन मैक एड्रेस इज ऑल एफ. नाउ दिस इज अ ब्रॉडकास्ट ट्रैफिक, ये एक ब्रॉडकास्ट ट्रैफिक है और हम इसको फॉरवर्ड कर देंगे. डन. तो देखने में सेम लग रहे हैं, अननोन यूनिकास्ट फ्लडिंग भी एंड broadcast भी, but there is a big difference, which is the MAC address entry in the destination MAC address column. I hope आप सभी को क्लियर होगा फंडा. आज के लिए इतना ही, कल मिलते हैं. थैंक यू.